folks, we are taking the part 3 video of this exercise 4.1 and we are taking up the 5th problem. Same way, by principle of mathematical induction, we are supposed to show whatever they have asked us. Let's see the 5th problem. It says that it is 1 into 3 plus 2 into 3 squared plus 3 into 3 cubed plus n into 3 raised to n. You've got to show that this is equal to 2n minus 1 times 3 raised to n plus 1 plus 3 by 4. Like we've done before, let Pn represent the given mathematical statement to show that P of 1 is true. Means in the step 1, if you have to do that, from the left hand side first term and from the right hand side wherever n comes, there we have to put 1. And let's see how it comes. This is 1 into 3 and on the other side it's 2 into 1 minus 1 times 3 raised to 1 plus 1 plus 3 whole by 4. Now let's see what it is. LHS is 1 into 3, that's 3. And RHS is 2 into 1, that is 2 minus 1, it's 1. 3 raised to 1 plus 1 means 3 squared plus 3 by 4. So it is 3 squared plus 3 by 4. So 9 plus 3 by 4, 12 by 4. So that is 3. So we are getting 3. LHS is equal to RHS, P of 1 is true. Now we have to show that in the step 2, assume that P of k is true. Wherever n is coming, we are putting k. So what will come? 1 into 3 plus 2 into 3 squared and so on. K into 3 raised to k is equal to 2k minus 1 into 3 raised to k plus 1 plus 3 by 4. That is, we have assumed. Now to show that P of k plus 1 is true, what we do is, one more additional term will come. For that, wherever k is coming, we will put k plus 1. So this is our k into 3 raised to k, and then in this term, wherever k is coming, put k plus 1. So you will get this as k plus 1 into 3 raised to k plus 1. All this has to be equal to what? Now for that, wherever, as I said, k is coming, they will put k plus 1. So just check what this will be. It will be like 2 times k plus 1 minus 1. That means 2k plus 2 minus 1. That means 2k plus 1. Right. So you have got to show that this is equal to 2k plus 1 times 3 raised to k plus 1 plus 1 k plus 2 plus 3 whole by 4. So we will start with the LHS. And in the LHS we have 1 into 3, 2 into 3 squared and so on. K into 3 raised to k, and you have k plus 1 into 3 raised to k plus 1. Till here terms we know that it is going to be 2k minus 1 into 3 raised to k plus 1 plus 3 by 4, and this term is k plus 1 times 3 raised to k plus 1. So if you want right away, let's equalize the denominators. So you can have this multiplied by 4, this also multiplied by 4. So you will have, when you take the terms, when you have the denominator, 2k minus 1 times 3 raised to k plus 1 plus 3 plus 4 times k plus 1 into 3 raised to k plus 1 whole by 4. That's after equalizing. Now when we carefully see these both terms, they are like terms. So you can have 3 raised to k plus 1 common, and uncommon terms 2 raised to 2k minus 1 plus 4k plus 4 and the plus 3 by 4. So we are very closely, we are approaching the RHS. In the RHS you want 1 plus 3 and by 4, that has come. Only now this has to get modified. So for that what will happen, you just take this is 6k and this is 3. So this is 3 raised to k plus 1 times 6k plus 3 by 4 plus 3. So you could have a 3 coming out from here. If you would have a 3 coming out, then 2k plus 1 would be left. If you take a 3 common, that 3 and this 3, they are same base, so the powers will get added up. A raised to m into a raised to n is a raised to m plus n. Like that, that will become 3 raised to k plus 2 times 2k plus 1 plus 3 by 4. And that is exactly our RHS. And so LHS is equal to RHS. So therefore pk plus 1, P of k plus 1 is true. And from steps 1 and 2, by principle of mathematical induction, these two, this result is proved. That is our problem number 5. Let's quickly move to problem number 6 and check what they say there. So the format, we need not change. The format is going to be the same. We are only going to change the terms and the working. That is all that is going to change. So let's see what's the sixth question. It says that 1 into 2, 2 into 3 and so on. So it says that it's a sixth problem. 1 into 2 plus 2 into 3 and so on. The last term is n into n plus 1. That is equal to n into n plus 1 times n plus 2 by 3. So this is how the working, this is what we are supposed to be showing. So as usual, we do it in 2 steps. First, let P of n represent the given statement, and we have the step 1 to show that P of 1 is true, where we take 1 into 2 first, and wherever n is being there, then we are going to substitute 1 and we are going to get this, and we are going to show this. LHS is 1 into 2, which is 2 itself, and RHS is 1 into 1 plus 1, 2, 2 plus 1, 3 by 3. They'll cancel each other, you get 2. So LHS is equal to RHS, and therefore P of 1 is true. Now, assume that P of k is true. In the given statement, wherever n comes up, there we'll substitute k, and we'll see how this is coming. K times k plus 1 is k times k plus 1 into k plus 2 by 3. So, using this, you have got to show that pk plus 1 is true. So pk plus 1, on the other hand, what are the terms? It is 2 into 3 and so on. K times k plus 1 plus k plus 1 into k plus 2. As I said, wherever k comes, there we are substituting k plus 1, and that's how you get the terms. Now here also, wherever k is coming, there we'll have k plus 1. Like that, we have k plus 1, k plus 2, k plus 3 by 3. This is what we are supposed to show. Okay, having done this, let's quickly go get across seeing how we'll be able to solve this. We'll consider the LHS. In the LHS, we have 1 into 2, 2 into 3 and so on. First, k into k plus 1 and then k plus 1 into k plus 2. So, this is a known term for us, and that will come to, it comes to k into k plus 1 into k plus 2 whole by 3, and here we have terms, so many terms are there, k plus 1 and k plus 2, we have k plus 1 and k plus 2. So when we look up the terms, k plus 1 and k plus 2 is there, so we can have them common, so we'll have k plus 1 and k plus 2 common. And what are we left with? We are left with k by 3 plus 1. So we could have it equalized, and when we equalize it, this will come to into 3 into 3. So it will come to k plus 1 into k plus 2, k plus 3 whole by 3. Whether that is equal to our RHS? Yes. So this is equal to the RHS. So LHS is equal to RHS, and therefore P of k plus 1 is true from steps 1 and 2. Given mathematical statement is true by P and I. So this is how we finish the problem of 5 and 6. The remaining problems we are taking it up in our next video. Thank you.